truth is, there's this gap between what is understood about global warming by the relevant scientific community and what is known about global warming by the people who need to know, and that's the public. The truth is, we have an emergency, and yet it's not obvious. The reason that can be is because of the inertia of the climate system. The ocean is 4 kilometers deep. The ice sheets are a few kilometers thick. They don't respond quickly to forcings. But once they do begin to respond, and that means the system has not yet come to equilibrium with the changes in atmospheric composition that humans have already brought about. And the problem is that once the system does begin to respond, it can pass tipping points where dynamics takes over and you sort of lose control of the system. And the bad news is we've already passed into a level of atmospheric CO2 that will be dangerous if we leave it there. The good news is that we could solve the problem, and there would be other benefits of doing that. Just as one example of a tipping point, ice sheets. If ice sheets once begin to disintegrate and slide down the slope to the ocean, then obviously it's too late. The dynamics has taken over, and you're going to get the consequences. And species extinction also, because again, these are nonlinear systems because there's interactions among the different parts. Some species depend upon others. So once you start to cause species to go extinct, you can affect others and end up with mass extinctions. And in both of these cases, we know from the Earth's history that that's happened a number of times. There have been warming of several degrees, and we've caused half or more of the species to go extinct, and over millions of years, new species evolve. But that's a time scale which humans can't imagine. We will be leaving a much more desolate planet if we push the system to that extent again. That's my first grandchild, and I first used this. I had decided after testifying in the 1980s that I didn't want to be involved in the public aspect of this discussion because I think what I can do is science, and there are other scientists who are articulate and who like to talk to the media, and so I would always refer reporters to Steve Schneider and Michael Oppenheimer. And even when I showed this, the reason I did, I had a talk at Lamont Observatory. The day before, there was an article in the newspaper that called me the grandfather of global warming, and I was showing that I really was a grandfather. It wasn't until several years later, even at the time I took these photos, that's Sophie, a little bit older, and her brother Connor. I was using this to explain the physics of global warming, which is very simple. It's when you add gases like CO2 to the atmosphere, it makes the atmosphere more opaque at infrared wavelengths. Those are the wavelengths where the Earth radiates heat to space. So if it becomes more opaque, that means the radiation to space will be from a higher level. And because the temperature falls off with height, that means there will be less radiation to space. And that means temporarily you create an imbalance where you're radiating less energy to space than the Earth is getting from the sun. And that will cause the Earth to get warmer if it's getting more energy than it's radiating. So it's very simple, and we can now prove this and quantify it very well. Because where does this excess energy go? Well, it can't be in the atmosphere. The atmosphere has a very small heat capacity. It's mainly in the ocean, which is, as I say, 4 kilometers deep. It takes a long time for it to warm up because the planet must warm up until it gets to the point where it's radiating back to space the same amount of energy that it's absorbing. Well, what we see when we now hit, there have been about 3,000 so-called Argo floats distributed around the global ocean. These have an instrument package on them that yo-yos down to a 2-kilometer depth and then yo-yos back up. And it, among other things, it measures the temperature. So we can tell how much, whether the ocean is gaining energy. And what we find is that it is gaining energy. That confirms that just what we expect, but it also tells us how much more the planet is going to have to warm up in order to restore energy balance with space. What it tells us is that we've only experienced so far about half of the warming that we will get due to the gases that are already in the atmosphere. And this is a really ironclad test of the status of the climate, of the status of the planet. So far, the planet has warmed. The temperature fluctuates from year to year a lot because of just the chaos of the atmosphere and ocean. But if you average over 5 years or 11 years to take out the El Nino cycle and the solar cycle, then you see that the warming has become almost linear over the last 30 years. And it's warmed about 0.8 of a degree Celsius, which is about 1.4 degrees Fahrenheit on global average. It's still, however, not easy for people to see this because the fluctuations in temperature from one year to another, and especially from one shorter time scales, one season to another or 1 month to another, can be larger than 0.8 of a degree because weather fluctuations are much larger than that. So last winter was cold. These are temperature anomalies relative to the 1951 to 1980 average. And in the United States, at least the eastern 2/3 of the United States, and Europe, it was colder than the 1951 to 1980 average. But of course, averaged over the planet, it was one of the warmest years. In fact, 2010, averaged over the whole year, was the warmest year in 130 years. The winter temperatures, I'm going to sort of skip over this. The reason for the cold winters is associated with the Arctic oscillation. When you have high pressure in the Arctic, that will tend to push cold air outbreaks to middle latitudes. And both of the last 2 years have had extreme Arctic oscillation indices, which, whether or not that's just, is probably just chaos, because if you look at the last 10 years, the temperature, that's the red curve in the United States, 8 out of the last 10 winters have been colder, or have been warmer than the long-term average. If you want it. And just 2 of them below average. And it's kind of similar in Europe. In fact, in the summer in Europe, the last 10 years have all been warm. According to the long-term climatology, they've been warmer than normal. Back in the 1980s, when I testified in 1988, and the paper that was attached to my Senate testimony, I said that the frequency, I had these colored dice to show that even though the warming within a few decades is still going to be smaller than the weather fluctuations and even averaged over a season, if you're perceptive, you can see that the frequency of warmer than normal seasons will be increasing. And I argued that it would, by the early part of this century, that it should have shifted from 2 sides of the dice being red to 4 sides of the dice being red, which would mean it should have got up to this dashed line. And it's almost got up there. And if you look at the extremes, the extremes that occurred more than 2 standard deviations above the normal seasonal mean temperature in the summer. Well, this is the winter, and this is June, July, August. What was 2 standard deviations? That means this occurred 2.3% of the time in a period of climatology from 1951 to 1980. But it's now the dark, this last year, 2009, 2010, that occurred 30% of the time instead of 2%. And 39% of the time, 39% of the area in last year, last summer. So in the summer, temperatures are less noisy than winter temperatures because the winter temperature is affected by these Rossby waves of dynamics. And so people in the summer should begin to see, although still the summer in 2009 was cool in the United States, but boy, there weren't very many places in the world that was true. Anyway, our understanding of this is based not mainly on climate models, as contrarians will say. It's based on understanding the Earth's history and how the Earth has responded to forcings, to changes in the boundary conditions in the past, changes in atmospheric composition and surface properties, and also ongoing observations, global observations. And models help, but they're not the primary source of our understanding. And I'm not going to talk much about this, except over the last 65 million years, there have been huge changes in the Earth's climate. Up until 34 million years ago, there were no ice sheets on the planet. It was so warm. And this temperature change, we know, is associated mainly with the amount of carbon dioxide in the atmosphere. There was more than 1,000 parts per million of CO2 in the atmosphere 50 million years ago, because naturally the amount of CO2 in the atmosphere is determined by the balance between the source of CO2, which is volcanoes, and the sink, which is the weathering process, which carries sediments to the ocean floor and deposits carbonates on the ocean floor. And so it depends upon continental drift. And the situation was such that when India, 65 million years ago, was in the South Indian Ocean, it was moving north at a rapid rate of about 20 centimeters a year. And 50 million years ago is when it crashed into Asia and pushed up the Himalaya mountains, and the volcanic activity associated with that is what caused the large amount of CO2, which caused the planet to be so warm that there were alligators in Alaska. It was tropical climate in the polar regions. But even though that's interesting, I won't talk about that more, except to say that it does, because people will argue, they say, well, gee, there have been larger natural climate changes in the Earth's history. And that's right, but those climate changes occur on very long time scales. And if you look at the rate at which this imbalance between volcanoes and weathering is of the order of 1/10,000th of a part per million of CO2 per year. And when that's maintained for 1 million years, that means it changes atmospheric CO2 by 100 ppm. But now humans are changing CO2 by 2 ppm per year. So we're 4 orders of magnitude more powerful than this natural force. So the natural changes we totally dominate over that. So future climate on any time scale that humans are interested in is going to be determined by humans, not by natural forces. We're now overwhelming them. And if you went back to more than 450 ppm, the different ways of estimating when Antarctica became cold enough to have ice on it, but we estimate that it was about 450 ppm. Well, if we burn all the fossil fuels, we'll have a lot more than that. We will be heading the planet back toward the ice-free state. It will take a while to get there. Ice sheets don't disintegrate immediately, but once they start to go, it won't take all that long. Now, global observations, we began to have satellite measurements in the late 1970s, which here's a graph of the amount of sea ice that remains in the Arctic at the end of the summer. And that has decreased by about 30% over the last few decades. The last summer, last fall, the Northwest Passage was open, and it's been open twice in the last few years. That, as far as we know, those are the only times in history that there was so little sea ice in the Arctic that you could sail a ship from the Atlantic to the Pacific. We also observe from satellites that the area on Greenland that has melting, it fluctuates a lot from year to year depending upon the weather, but overall there's an increase in the area with melting during the summer. And that meltwater will go to a low spot on the ice sheet where it burrows a hole in the ice sheet that goes all the way to the base of the ice sheet. And that's one of the mechanisms that contributes to the increase in the discharge of these giant icebergs to the ocean. And still, we did not know. Based on only this information, you wouldn't know if Greenland is getting smaller or bigger, if the ice sheet is growing or shrinking, because as the atmosphere becomes warmer, you get more snowfall. It holds more water vapor. And places that it's cold enough to have snow, you'll get more snowfall. But now, beginning about 8 years ago, we have this satellite called GRACE, the gravity satellite, which measures the gravitational field of the Earth with such a high precision that you can see changes in the mass of the ice sheets. And during the winter, the ice sheet gets heavier, and then during the melting season, it loses mass. But overall, Greenland is losing mass at a rate of a couple of hundred cubic kilometers per year. And Antarctica is now also losing mass at an increasing rate. And it seems that the rate of mass loss is actually accelerating. It's faster in the last few years than it was. But this record is too short to really see how that's changing. Another expected effect of global warming is an expansion of the subtropics, because the rising motion in the tropics associated with the heating of the surface, it gives that circulation cell, the subsidence that causes the subtropics, that Hadley cell is expected to expand as the planet gets warmer. And what we observe empirically is that on the average, it's expanded by about 4 degrees of latitude. And that's beginning to affect the southern United States, the Mediterranean region, and Australia in the southern hemisphere. And it's one of the reasons that the forest fires have been increasing in these regions. And the fires burn hotter, which makes it more difficult for the forest to recover because it burns the seeds as well as the trees. Another effect is all around the world, in the Andes Mountains, the Rocky Mountains, the Himalayas, the Alps, the glaciers are receding. And that is of practical importance because some of the major rivers of the world, including the Ganges and the Brahmaputra, rivers that provide fresh water to actually billions of people, during the dry season, more than half the water in those rivers is coming from melting ice. So once these glaciers are gone, then the seasonal cycle of fresh water will be very different. You get bigger floods in the spring, but the rivers will tend to run drier in the dry season. Another effect is on coral reefs, which are under stress for several reasons, but two of them are the increasing temperature of the surface waters, which causes coral bleaching, causes the coral to expel their symbiotic algae and to die, but also the acidification of the ocean. As the ocean takes up carbon dioxide, it becomes more acid. And those animals that have carbonate skeletons or carbonate shells are obviously hindered by the water becoming more acid because eventually it dissolves the carbonates. So for a number of reasons, we estimated that if you want to keep a planet that looks like the one that has existed the last 10 or 12,000 years during the Holocene, then you had better keep CO2 from being more than 350 parts per million. And now we can actually quantify that better based on these newest measurements of the Argo floats, which tell us how far the planet is out of balance. But as I say, if we want to keep a planet that looks like the one that's existed during the development of civilization, then we need to keep CO2 less than 350 parts per million. And the problem is that so far we've burned these portions of the fossil fuels. How much there is left in the ground there's some dispute about that, but there's plenty to cause several hundred parts per million of CO2 in the atmosphere, and we just can't do that. The principal conclusion that I would draw is that we should be phasing out coal. It's very difficult to suddenly stop using oil and gas, and most of that's owned by countries in the Middle East and Russia, and it's going to be very difficult to stop them from selling that. We expect that's going to happen. But we could phase out coal use, and we could refrain from using these unconventional fossil fuels. If we did that, then CO2 would peak at something over 400 ppm as the oil and gas begin to run out, and then it would slowly begin to decline as some of the CO2 is taken up by the ocean and the biosphere. And if we really had a huge reforestation, we could get CO2 to come down faster. So it's possible to get back to 350 ppm, but that would require that we phase out coal use and not develop the unconventional fossil fuels. And for that matter, we shouldn't be pursuing the last drops of oil in the most extreme environments, because we're going to have to get some of that CO2 back out of the atmosphere. But what's really happening, all the governments in the world and fossil fuel companies are just basically assuming we're going to use all the fossil fuels. And the United States has signed an agreement with Canada for a pipeline that will carry tar sands oil to Texas oil refineries. And they're still building coal-fired power plants all around the world. Even though there was nominally a climate agreement in the late 1990s, the emissions of CO2 actually have accelerated since then. The last few decades, up until year 2000, emissions were going up 1.5% per year. But in the last decade, despite the economic downturn of the last couple of years, the growth rate has been 2.5% per year. So there's this gap between the rhetoric and the reality. Politicians will say we have a planet in peril, and they say that they're doing things, but any of the policies, in fact, are very small perturbations to business as usual. So it's more a case of greenwash than actual actions. And the problem is that this is an enormous moral issue. It's a question of intergenerational injustice. Because today's adults are getting the benefits of burning fossil fuels, and the problems are going to be visited on young people and future generations. Our parents didn't know that they were causing a problem. Now you can only pretend that you don't know. This is my other two grandchildren, my son's children. Jake is a gentle giant. He's in the top 1% for his size, for his age. And he thinks he can protect his baby sister, who was 2.5 days old when I took this photograph. But what Jake doesn't know is that this problem, if we continue to burn fossil fuels, it's going to be a situation that's out of their control. The fundamental problem is that fossil fuels are the cheapest energy. And they're cheapest partly because they're subsidized, but mainly because they are not made to pay for their cost to society. The air pollution, which kills more than 1 million people a year around the world, is mainly from fossil fuels, air and water pollution, and those health costs are borne entirely by the public, not by fossil fuel companies. And the costs of climate change, which will grow to be enormous, are also not paid by the fossil fuel companies. So I argue that it's as certain as the law of gravity. As long as fossil fuels are the cheapest energy, then of course we're going to keep using them. Therefore, we need to put a gradually rising cost, a gradually rising fee on fossil fuels, which should be collected from the fossil fuel companies at the first sale, at the mine or the port of entry. And the money, in order for the public to accept this, because it is going to cause energy to be more expensive, that energy which comes from fossil fuels. In order for the public to accept it, the money that's collected should be given to the public. So those people who do better than average job in limiting their fossil fuel use, they will actually get more in the dividend than the monthly green check, which would actually be distributed electronically to bank accounts or debit cards. And if the public and the business community knew that this fee was going to rise, then they would, make the investments to move toward clean energies. But as long as we subsidize fossil fuels, we'll just keep using them. And instead, what we get from the government is proposed cap and trade, which is designed by big banks. There's absolutely no reason to bring JP Morgan Chase and the other big banks into trading because you wanted just a simple, transparent system and avoid volatility in prices. That, I argue, would work, and there's a group called Republicans for Environmental Protection, and it may be a small group, but they argue that this is exactly what you should do. Then the market, if you just read his last comments, he says it's transparent, market-based, does not enlarge the government, leaves energy decisions to individual choices, takes a better safe than sorry approach to dependence on oil and keeping greenhouse gases out of the atmosphere. And he says it sounds like a conservative plan, but it's very hard to communicate this situation to the public because there are a lot of people who are making a lot of money off of fossil fuels, and they're extremely good at influencing the public misunderstanding of this whole topic. And as I say, it's an intergenerational issue. And it's contrary to everything that our country stands for. And I have this quote here from a message from Jefferson to Madison about, Jefferson was actually talking about the soil, that we should not deplete the soil for the next generation. So we should, but the same thing is true for the atmosphere and climate. And most cultures believe in obligation to future generations. But governments think they can do whatever they please. And the public does not understand the situation, I think. So one thing we're doing is writing, this is Sophie, this last summer, when we were planning to make this million-letter march to try to get people to write letters to politicians. So she on this, we just wanted to take a photo of her, but she wrote a letter on the spot, and she was pretty sure that I would like that letter because, among other things, she said, why don't you listen to my grandfather? And we were celebrating her good letter. Now, the other topic I want to mention quickly, I do have some optimism because China is making enormous investment. They're now #1 in production of solar power, wind power, and nuclear power. And They're doing it at a scale that they will be able to sell this technology to the rest of the world. It's what we should have been doing, but have been instead supporting fossil fuel industry. And the other approach is the legal approach to try to get the government to do its job. My argument is that if you look at a Declaration of Independence, starts out by positing that all people are created equal. And that's the basis in the Constitution for equal protection of the laws. And my argument would be that young people are also people. And the courts should protect them. In the same way that the courts told the government that it had to give a plan for desegregation, to give equal rights to minorities, it could require the government to give a plan for how it's going to protect the rights of young people. But the lawyers actually say there's a different approach, and that's what is on Mother's Day, about 10 days from now, there are going to be cases launched in a number of courts across the United States and also in a few other countries, in which the request to the courts will be to make the government provide plans for how it's going to phase down CO2 emissions at a rate that would stabilize the climate. And that's what I'm currently writing a paper on, which, because I'm providing a scientific rationale for these court cases, and I have to get this done within the next, by the middle of next week. And with regard to your students, I would be happy, I'm just writing that, and I want it to be in a language that can be understood by the public. And so I'll be happy to give you the draft of what I'm working on. And have your students can help me do this, finish this job. But what I show, well, I've already shown you these curves for the world getting warmer, but if you look at the Earth's history, the current interglacial was this warm period that we're living in, which is now about 12,000 years long, is not quite as warm as the previous interglacial period, the Eemian, about 130,000 years ago, or this one about 400,000 years ago. However, the temperature difference is less than 1 degree Celsius. If you want to find a world warmer, more than 1 degree Celsius warmer than the Holocene, you have to go back really into the Pliocene. This is now millions of years here. And then it was probably less than 2 degrees Celsius warmer. And we're heading the Earth down a path where it's going to be more like the Pliocene if we don't change our history, our course. And this is another chart that I'll use. This is just showing we now have quantified. This last 6 years is the time in which we have these Argo float measurements covering the whole world ocean. And it shows that the ocean is taking up heat at about more than half a watt. And there's also energy going into melting of ice into the land, getting warmer. And so the total imbalance is about 0.6 of a watt. And here's the real problem. It's the way that carbon dioxide, the carbon cycle works. When you insert into the atmosphere a pulse of carbon dioxide by burning fossil fuels, that pulse will decay fairly rapidly. So this is a 50 ppm pulse of CO2 is added to the atmosphere. It decays so that after 25 years, it gets down to about 50% is remaining in the atmosphere. The other 50% is taken up mostly by the ocean and also by the biosphere. But even 500 years later, almost a fifth of that CO2 is still in the atmosphere. And it's going to stay there until the weathering process takes it out and deposits it on the ocean floor. But that takes thousands, tens of thousands of years. So what that means is right now, so we're here. If we stop burning fossil fuels, then completely today, then CO2 would slowly decrease. And it would get below 350 ppm by the middle of the century. But if we stay on business as usual for 10 more years, and then suddenly stop burning fossil fuels, then we won't get back to 350 until 2300 or something like that. And if we stay on business as usual until the middle of the century, and then stop burning fossil fuels, it'll be about year 3000 before you get back to 350 ppm. So we're creating a problem which will soon be unsolvable. Right now, there is another thing you can do besides wait for the ocean to take up the CO2. You can try to reforest, because we've put about 100 gigatons of carbon into the atmosphere by burning forests. And if we had a really ambitious global reforestation program, especially on marginal lands that are not useful for crops, we could extract as much as 100 gigatons of carbon, I think. You should have improved agricultural practices also so that the soils retain more carbon. But if you did that, and if you began phasing out CO2 emissions at 6% per year, then you could get back to 350 ppm by about the end of the century. And that's what's going to be requested in these court cases, that the government should have a plan how they're going to reduce their fossil fuel use by 6% a year. But if you stay on business as usual for another 10 years or another, say, until 2030, then it takes a lot longer to get back to 350, a couple of hundred years. And it's a question of how, so we are overshooting into a dangerous level, but it's a question of how long can we be at a dangerous level without things like ice sheets collapsing. Anyway, as I say, I'm writing the scientific justification for why the government should be required, for the sake of young people and future generations, why they should be required to give a plan for it. Because right now they're just assuming we can just burn all the fossil fuels. They don't get it. Thank you.